DMT tone structure in ADSL, asymmetric digital subscriber line. The DMT tone structure is the blueprint for how the copper wire's frequency spectrum is organized. It defines how many bins exist, what each one does, and how they are separated to allow voice and data to coexist. According to the ITU-TG.992.1 G.DMT standard, the spectrum is divided as follows: the basic parameters total bandwidth, 2 MHz bandwidth, spacing exactly kilohertz, total number of tones, bins, calculated as symbol rate, symbols per second, plus a small overhead for the cyclic prefix, resulting in a total line rate of kbaud. Tone allocation, the frequency map. The 256 tones are assigned specific roles to prevent interference between voice uploads and downloads. Tone frequency range service/usage range 0 to 5 to kHz POTS, voice reserved for traditional analog telephony 6 kHz guard band, a buffer to separate voice from data. Upstream, upload 25 tones used to send data from the 7 to 31 to kHz user to the MSAN 32 kHz guard band, separates upstream from downstream. Downstream, download 223 tones used to receive data 33 to 255 to kHz from the internet. Special purpose tones within this structure. 2 specific tones have non-data jobs critical for keeping the connection alive. Pilot tone, tone 64 located at kHz. This tone does not carry user data. Instead, it sends a constant, known signal that the receiver uses to synchronize the clock and track frequency shifts in real time. Nyquist tone, tone 256 generally unused for data, marking the upper boundary of the ADSL spectrum. Overlap versus non-overlap spectrum. There are 2 ways the DMT structure handles the border between upstream and downstream. 1 FDD, frequency division duplexing. This is the standard non-overlap method described in the table above. Tones 7 to 31 are purely for upload, and 33 to 255 are purely for download. It is simpler and reduces interference. 2 overlap spectrum. In some configurations, Annex A, downstream data is allowed to start as low as tone 6. This means downstream and upstream share the lower frequencies. While this can increase download speed, it requires complex echo cancellation to keep the signals from crashing into each other. Bit loading capacity per tone. While the structure provides 256 slots, not every slot is equal. Each tone can carry between 2 and 15 bits per symbol. Low frequency tones, near the start of the downstream block, usually carry the most bits because they suffer less attenuation. High frequency tones, near tone 255, carry fewer bits as the signal weakens over distance. Summary of DMT tones of G.DMT. The ADSL DMT structure is essentially a 256-lane highway. Lanes 0 to 5 are for the old-fashioned cars, voice. Lanes 7 to 31 are for cars going one way, upload. Lanes 33 to 255 are for cars going the other way, download. Where DMT is applied, discrete multitone, DMT, modulation is the global standard for high-speed communication over copper wires. Because of its incredible ability to handle noise and varying line lengths, it is the foundation for the entire XDSL family and several other niche applications. Here is a breakdown of where DMT is currently utilized. 1. Residential and business broadband, XDSL. This is the most common application of DMT. It is used to deliver high-speed internet over traditional telephone copper pairs. ADSL/ADSL2+, the most widespread version. It uses 256 or 512 DMT bins to provide speeds up to 24 Mbps VDSL2, used in fiber to the cabinet, FTTC, setups. It uses up to 4096 DMT bins to achieve speeds up to 100 to 300 Mbps G.fast, the newest evolution, designed for very short copper runs, under 500 meters. It uses a massive DMT range, up to 106 MHz or 212 MHz, to hit speeds of 1 Gbps/2. Multi-Service Access Nodes, MSAN. As we discussed earlier, the MSAN is the hardware located in the telephone exchange or street cabinet. The line cards inside the MSAN use DMT-based chipsets to communicate with the modems in customers' homes. The MSAN uses DMT to aggregate thousands of individual subscriber lines into a single high-speed fiber backbone. 3. Power line communication, PLC, DMT, often referred to as OFDM in this context, is used to send data through the electrical wiring in a home or across the power grid. Home plug standards, devices that plug into wall outlets to extend a home network use DMT/OFDM because electrical wires are extremely noisy, due to appliances turning on and off. DMT's ability to notching out interference is perfect for this environment. Smart grids, utility companies use DMT to communicate with smart meters over long-distance power lines. 4G.HN, Next Generation Home Networking. G.HN is a unified standard for home networking that can run over any wire, power lines, coaxial cable, or phone lines. 4. It relies heavily on DMT to ensure that data can pass through different types of medium while maintaining high speeds and stability. 5. Specialized industrial applications. Video over DSL. High bandwidth industrial cameras in mines or tunnels often use DMT-based modems to send high-definition video over old twisted pair copper cables where installing fiber is too expensive. Elevator intercoms and displays. Some modern elevator systems use DMT to transmit data and video to the moving car using the existing traveling cable. Why is DMT used in these specific places? In all the examples above, the common theme is a hostile transmission medium, copper wires, power lines. DMT is used whenever a wire wasn't originally meant for high-speed data because it can, 1. Avoid frequencies with high interference. 2. Adjust to the length of the wire automatically. 3. Support asymmetrical traffic, giving more bins to download than upload. 2B1Q versus DMT. 2B1Q and DMT, discrete multitone, are two methods used to encode and transmit digital data over copper telephone lines. While both are used in DSL, digital subscriber line, technologies, they represent two different generations of communication philosophy. One is a simple, single-carrier baseband code, while the other is a sophisticated, multi-carrier modulation system. 1. The core technology feature 2B1Q, 2 binary, 1 quaternary, DMT, discrete multitone, type line coding, single-carrier, modulation, multi-carrier, groups 2 bits into one of 4 voltage, divides bandwidth into 256 separate sub-mapping levels. Channels, bins. Very low, easy to implement in high, requires digital signal processing complexity hardware. DSP, and FFT. Uses a single broad frequency, uses many narrow, parallel frequency spectrum ranges. Standard ISDN BRI, IDSL, and early ADSL, ADSL2+, and VDSL. Use HDSL. 2B1Q, the efficient line code 2B1Q stands for 2 binary, 1 quaternary. It is a form of pulse amplitude modulation, PAM4, that maps 2 bits of data to a single quaternary symbol, one of 4 specific voltage levels. How it works: instead of sending 0 as low and 1 as high, it uses 4 levels. Example. Because each symbol carries 2 bits, the baud rate, the number of pulses sent, is half the actual bit rate. Strengths: it is very simple to design and consumes very little power. It was the gold standard for early digital telephony, ISDN. Weaknesses: it is a baseband signal, meaning it occupies the same low frequencies as traditional voice. It is also vulnerable to noise that affects the entire frequency band. If a specific frequency is blocked by interference, the whole 2B1Q signal suffers. DMT, the intelligent multi-carrier. DMT is essentially a version of OFDM, orthogonal frequency division multiplexing. Instead of sending one big stream of data, it breaks the available frequency spectrum into many small subchannels or tones. How it works: in a standard ADSL setup, the line is divided into 256 subchannels, each wide. Each channel acts like an independent modem. Adaptive loading: this is DMT's killer feature. If one subchannel has a lot of